Codeforces. We'll solve again some 1300s, and we are basically getting ready for our contest tomorrow. So let's solve 1300 just so that we can solve A and B problems quickly. And okay, okay, cool, cool. We will have my uh, code notes, sticky notes. Yeah. Okay, I wanted this. This is my format on the C++, and then online C++ compiler. Let's solve two questions quickly. Okay, to start is the toughest part. Once we can do it for 15-20 minutes, it'll be easy. Okay, okay. I have this 1300. Okay. We won't see the see which topic is it from. I'll just pick randomly. Let's do two questions. And then, okay, a given integer a in array of a of an integer in one operation will perform the following two-step move. Choose an integer x. Okay. Okay, 10 power 9, 0, 10. Replace each AI with AI minus x mod. Okay, absolute value. For example, by choosing x to say, oh, we'll change to 318. Yeah, that makes sense. Well, okay. Okay. Construct a sequence of operation to make all elements of a equal to 0 in at most 40 operations or determine that it is impossible. You do not need to minimize the number of operations. Uh, okay, Mm, okay, we are given 40 operations. Determine that it is impossible. And you do not need to minimize the number of. Okay, 40 is the limit, and we don't need to minimize. Just need to return yes or no. Okay, and then -1 if it's impossible. Output two lines. The first line should be contain k, the number of operations. Second line should be k integers. Okay, sequence of operation. Okay, fine, fine. If they're you can output any of the solutions. Okay, we have to make all of them zero, right? So it's just 40 operation and can be big. Okay. What if we choose a really big value? What's the limit over a? A is still 10 per 9. So let's say I take 10 per 9, and is it a positive value? A is a positive value. Okay, so if I take a really big integer and then everything becomes okay. What if I take the maximum? What if I take a as maximum of the values which are given there? What happens then? So let's say I have sorted it. I can sort it. The order doesn't matter. So I can have a sorted array. If I take the maximum and then I do the mod, what will I have? Uh, just the maximum minus that thing. I can have this. Okay. And what if I take a middle value? What happens then? If I take a middle value, then I get something of this sort. Okay. Mm, okay. Okay. What if I take a middle value again? I get Hmm. Okay. Let's not go with the output, otherwise it will try to confuse us. I'll go with the output later. Hmm. So let's see minus 1, 2, 3, 4, 5. It is impossible to do 4, 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, and then we choose anything. Let's say I choose 5. Will become 0, 1, 2, 3, 4. Again, I take something. If I take, let's say, 3, what happens? It will become 2, 1, 0, 1, 2. If I take mm, mm, okay. We'll go down and then more n is 20 and perfect. So what I'm trying to do is hide the topics from the right hand side. Okay, 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 okay. What was the fourth, second last year? 80, 40, 20, 10. Let's take 80. Let's take 40. Let's take 30. Five, 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 five. So if I have same numbers, and then some zeros, we can take a by 2. Everything will become a by 2, 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 a by 2. And then we take a by 2 and it becomes 0, 0. Okay. What if I have 2a, and then 0, 0? So 2a, if I take a, what happens is it becomes a, it becomes 0. Is what I'm saying. Okay, you see that thing? So if you have a multiples, let's say if I have 3a, 0, 0, can I convert? So I'll take the a first, so it will become 2a, 0, a, and now if I have 2a, I can convert it to 0, 0, and it is okay, works. And then if I have 2a, a, multiple A is also work. What if multiple 2 is there? That will also work. What if I have 2A, sorry, 3A, 2A, and 0, 0. So if I take a A, it will become 2A, it becomes A, it becomes 0, A, A. If I take A again, it becomes A, 0, A, 0, 0. Okay, it's also possible to convert. Okay, what happens when I am taking the okay, everything is decreasing by A, but once it decreases by A, it starts increasing again. Okay, I see that. Okay, I see how that happens. 2A, 0A. Once again, A. Yeah, so once it comes till A, it either becomes 0 or it becomes A, right? It just keeps changing. 0A, 0A, 0. And then the bigger numbers can be decreased. So 80, 40, 20, 10, whatever this is, these are multiples of 10. So this is 8A, 4A, 2A, and A. What happens? We take A, it becomes 7A, 3A, A, and 0. Then it becomes 6A, 2A, 0, and A. It becomes 5A, A, 0. 4A, 0, 0, A. 3A, A, 0. 2A, 0, 0, A, A, 0. And then if I choose A, it becomes 0, 0, 0, A. The next step is from A 0. No, we want all same. What if I take A by 2? A by 2, A by 2, A by 2, A by 2, and then we're gonna make it 0, right? Okay, okay. I think I've got some hints. I'll be back in 2-3 minutes. Okay. Uh, at most 40 or so. I don't know. Okay. Yeah, I think it's not a solution. We can see hint in something. So even it with so I'm thinking a multiple of some number and then the minimum the number, let's say a 2a 3a. So a should be even. So if I have a 2a 3a 4a or 7a or xa and then a is even, I can make it as 0. This I found out. Okay. But what about some other case? If A is odd, if A is not even, then we can test it. Or we have odd multiples of A, 3A, 5A. That also works. So I have 0, 2A, 4A, A, A, 3A, 0, 0, 2A, A, and then 0, 0. So and then here A does not need to be. So this is also one case. So if A is even, then we can have anything. If A is not even, then we have to have A, 3A, all the odd multiples. Mhm. So if I have 1, 3, 5, 7, I should be able to do it. So 0, yeah, definitely I'll be able to do that. Um, hmm. A can be anything, right? Anything. Hmm. So I find GCD first. And let's say GCD is 3. So if we find is all odd, if it's all odd, then it works. Otherwise, it won't work. Hmm. Hmm. Is there any case I'm missing? So I am finding the GCD. What if all are even? But it can't all be even, right? If it had been even, I would have gotten a 2 in the GCD. GCD is odd, works only if all are odd. If GCD is odd, then definitely everything else is odd, right? No, few can be even few can be. If GCD is even, then works anyways. GCD is even, then we can make it. Yes, there can be only two cases: GCD odd or GCD even. I told GCD odd won't work. I tried working with GCD odd. It does not work. Zero or zero zero. Okay, now we have to do it in 40 operation. How do we do it? It's easy one. I just use the middle value 6. 5. आधा तो कर सकते हैं. The maximum value, we can make it half, but what happens to the other values which are less than that? that will also be less than equals to half. And what happens to the second maximum? That is also going to be less than half. So it's always better if I make it half. And then I can continue from there. Hmm. Hmm. Let's say it's a 7A and then I use a 9A. So if both are odd, then I get a 2A, even thing. And then if I use odd thing, so basically even odd, it reverses. And then, mm, mm, there are 40 operations, right? So if it is possible, then can we be able to do? So I have 10 to the power 5. I do 40 operation. Every operation, I am definitely able to make it half. Like every element, the biggest element, I can make the biggest element I can definitely make half, and the rest of the elements will be less than that. So uh, that that's what I can do. Yeah, that is a claim. Every operation I can do that. So every operation, if I can do that, and there are 10 to the power 9, there are 10 to the power 9 maximum. Should be able to get it down. To get it down to because half 2 to the power 40 is way too much. It's like 2 to the power 30 is 10 power 9 into more thousand. So this is like 10 to the power 12 trillion. So definitely we can make it 0 if it's possible. And then I have to give a array, right? Possible operation. So what I do is I pick the maximum value, I do the half and half of it, and I use it to deduct from the whole edge. Every time I do that, okay? What happens if I do that every time? Let's say I have this case 8A, 4A, 2A. So I take 8A by 4. So basically 4A is 0, 2A, 3A. Then I pick the maximum. 4, I do 2A, 0, uh, 0, A. Maximum is 2, I pick up A, 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 0. Maximum is pick up A by 2, A by 2, A by 2, A by 2, A by 2. Okay. Every operation I pick the maximum. Hmm. What if I had a 9A here? A and then 9A. I take 4. So it becomes 5 here. It becomes 4 here. It becomes 0. It becomes 2. It becomes 3. 8 over 2, so it becomes 3a, 2a, 2a, and 0, a. 8 over a, so it becomes 2a, a, 0, 2a, 2a, 8 over a, so it becomes a, 0. Okay, okay. So, it will take, mm, what point do I have to do it manually? Actually, I don't have to do it manually. Mm, I just give the a by 2, a by 2, a by 2, a by 2. But then I need to know when it becomes 0, right? Can I go with the whole array? So 40 into n should work, right? Okay, it should work. Yes, it is. Hmm. Yes, it is understand. Perfect. Okay, it is. GCD. GCD from X. This is there, right? But they have to change as well. This is last. Get a GCD. Then we'll divide by the GCD. If GCD is there, then we'll do some extra steps. GCD is off, we do not. So, GCD. Okay. While J less than equals to 4. While j is less than 40 is less than 10. We actually, yeah, we can add breaks inside the. We can do it in 14 to n. That's not a problem. So let's make an answer for anti. Yeah, less than n. Just anti t equals to n minus 1 by 2. So I do a out of I equals to mod absolute of ri minus t. Okay. Do a check. So anti check equals to 0 for anti zero. If the check is 1, so if array of I is greater than 1, then check becomes 0. Multiple should be less equals to 0. 1. So if check is 0, we continue. If check is 1, we break. Okay, makes sense. And every time what we do is I put this in my answer dot push back t into PC. Okay, so now if GCD is even to the 0, and what I do is two more steps, and else if it is odd, you do one more check. Check equals to 0. Sorry, check equals to 1, and for anti x belonging to a r, if x equals not equals to 0, then I can say check equals to. Basically, check if check is 1, that means all are 0, and I can just print my answer. Print answer. It's in the answer. Okay. Else I will see out minus 1. And over here, what will I do is I have two more steps, but I have to do this check. And what if I remove this effort? check equals to 1. So if it's here, so let's say if j equals to 40, I returns here -1 and then return. Okay. If all are 0, then I do. Okay. If all are 0, I can print the answer. Okay. And else I have two conditions. So if GCD is odd, then I say I will print -1. Else what I'll do is I'll say I have two more operations. Answer dot push back a by 2. So GCD 2 and then answer dot push back GCD by 2. So if count j plus 2 is equals to 40, then I say cout -1 and else I say cout else I say print answer. Um, okay, works. Okay, works. Just write a print answer. So void print vector print answer and okay, let's run this. Ha, it printed -1. Input was first the size and then cout and then values. So 1 5, what did it print? Okay, let's see. 1 5 it printed as minus. The GCD here is 1, and then I subtract, I do 3 and remove 3. Sorry, I'll remove 2, will become 3. I'll remove 3 by 2, that is 1, it will become 2. I'll remove 2 by 1, that is 1, it will become 1. And once it becomes 1 or 0, it checks here, right? If check equals to 1, it breaks. Okay. Okay, why don't we just print it out? Check why it's not going to. I will, what should I print? Let's print values here. Let's print cout t and cout j, and then we do, let's do this 2 0. That is correct. What is 0? 0 is 0. 1 1. That is correct. That is correct. And then comes, okay, check is fine. So if check equals to, and check equals to 1 for x not equals to 0. If everything is equal to 0, then print answer. Everything is not equals to 0, then GCD is flipped. Df, okay, let's not 1 0. 1 0. What is this? 1 0. Okay, 0 operations. Cool. 1 0 also. 4 6 8 minus 1. 4 6 8. GCD is 2. So 2 3 4. And then I do 2 becomes 2 1 0. I do 1 1 0 1. Now it stops. So, -1. What the heck? Let's copy this. 4. Really? 4? D is 4? How can that be? GCD, what's the GCD? Okay, right. GCD is always 1 as though we have to take it plus some element initially. Okay, okay. So, 1, 1. Let's see 4 to 1, 1. Okay. 4, 6, 8. First 4, 2, 1, 1. Okay, works. Okay, run this. What the hell? Memory limit is gone. Okay, this one is running fine. Let's see if this one's running. Be- Okay, does seem to do this. Which one is actually the problem? Is this the, is it the last one? Okay, I think it's the last one. Because there's no stop condition here. No, it did compile properly. What floating point exception? Code. What is floating point exception? Mm. What the hell? Oh, okay, okay, right. If GCD, AR is zero, if even one element is zero, okay, no, it's okay, sir. GCD, no, sir, not registered, then GCD, okay, just initialized, and then do have to do for them to actually seriously, GCD, okay, I think it should work. Then let's see the hints. I think it should be simpler in the hints. You're not allowed. Why can I not just enter this page? Somebody. Okay, it's the wrong answer. Let's just check the wrong answer. Just want to see. Hmm. Wrong answer. First question. Test case. Hmm. What the hell is this? What is this? Output answer. Okay. And what is this? What is 1512? What? Which question answer? What? What question? No, this is not the question. What the fuck? I was solving this one. What the fuck, bro? What the fuck? At least first test case should pass, because that at least I checked, right? We're running on test case 2. Wrong answer on test case 2. Fine, we check that. Wrong answer, you marked it impossible when it is possible. Test case 14. Somebody, okay, let's see the solution. Can you decrease maximum by half in one operation? Okay, I did that video tutorial. Okay, we have a video tutorial.
Okay, I will move to problem C. Yeah. Problem C says you are given an array of n integers. In one operation, you will perform the following two steps. Choose an integer x, or we can choose anything, and replace each ai with ai minus x, and so on. For example, we have x equal to 8, 5, our take absolute value, then our new array becomes 3, 1, and 2. These are the types of operations we can do here. Construct a sequence of possible. We can use at max 40 operations. Make possible. Okay, moving on to question. If all the elements are odd, like, yeah, difference odd can be one way. Like, if an array contains both odd and even numbers, the answer is impossible. Any questions on this one? Like, how do I say this? Because, like, let's say we have one, let's say a1 is odd and a2 is even.
Odd and even.
Any questions on this one? Like, how do I?
Yeah, definitely. Definitely.
Say this? Because, like, let's say we have one, let's say a1 is odd and a2 is even. If x is odd, a1 minus x becomes even, and a2 minus x becomes odd, remains odd, and we will always have both. We have both odd and even number. Then what? It was mostly trying to play around with the stuff here. Friends of, yeah, like, it's mostly like you will realize this when I share like the next idea, like how can you the proof and everything. But this why we came here, like, when like all the numbers are not a convincing proof. What I have said is, like, if there are odd and even numbers, then the answer is definitely zero. But it can be possible that all the odd number or all the even number can also give us impossible. We are not yet to come there. What I am saying is, like, let's first, yes, if array contains both odd and even numbers, some a1 is minus e1 is also an odd number. So if we had odd number in starting and we did operation with x equal to even, we again got odd and even numbers. And if we had x equal to odd, then odd minus odd becomes even, but even minus odd becomes odd. It's able to make everything equal to 0. Are even, then it is possible to make everything equal to 0. So any questions so far? Even, then one way to get some or make everything 0. Or if all the numbers are odd, then there is one way to get some or make everything 0. Or if all the numbers are even, then it is possible to make everything equal to 0. Power 9, 0 not 1 to 10 to the power 9, or I think 0 was also allowed, I don't know. Yes, 0 was also allowed. 10 to the power 9. Between 0 to 2 to the power 31. That is also a correct statement because 10 to the power 9 is less than equal to 2 to the power 31. Like I can say this, right? Okay, in starting, all of my numbers are between 0 and 2 to the power 31. Now what I will do is let's subtract 2 to the power 30 from each of them. So my numbers will change to range minus 2 to the power 32 to 2 to the power 30. And now when I will take absolute value, all the numbers will change to range 0 to 2 to the power 30. You see what I did here? Like I was told all the numbers are between 0 and 10 to the power 9. I just assume like one general condition a bit. Like instead of 10 to the power 9, I just said like let's say all the numbers are between 2 and 0 and 2 to the power 31. From every number, then my range changes to minus 2 to the power 32. Value will be between 0 to 2 to the power 30. Now the next bit is like let's subtract 2 to the power 29 from here. Everything will change from minus 2 to the power 29 and 2 to the power 29. And now if you take absolute value, see, going here. Like you see, like we keep repeating, everything would be between 0 and 2 to the power 28 and so on until you will have everything between 0 and 4. Like you can keep doing operations like this. Now we can do a minus 2 again here. Everything will be between 0 to 2. And then you do a minus 1 here. Everything will be between 0 and 1. Now everything is 1. Everything is 0 now. And if all the numbers are odd, we can do one more minus 1 operation to make everything 0.
Sir, so everything will turn out to be one. Then I can make it into this. And then if all are let's say even, then if all are odd, if all are even, then also we can.
And that was the idea. And yeah, like people in the chat also mentioned like one more idea is to just choose x equal to max a by 2 and keep doing this operation, and like you will always end up subtracting by 2 over here. And total operations here would be like 30 operations from 2 to the power 30 to 2 to the power 0, 30, 31 operations. and then we may need one extra one at last. Yeah, like now you don't really need that odd even idea. Like if you had this idea, you could have just checked at last if this algorithm gives zero or one or not. If this gives zero, then you print the answer. Otherwise, you just say it's impossible now. The reason I mentioned that was because otherwise it would have been difficult to prove later on once the idea was out. Like that was x equal to mid each time is another idea as well. You can take seal or floor, whatever you want, and at last you will reach a case where everything is either zero and everything is zero or everything is one. If everything is one, just do x equal to one once and you are done.
Okay. If I remove the GCD idea, I will remove the GCD. Okay. Everything is good. If it's possible, then we can always do that. So no need to put all these checks over here. Very true. Okay. What is it? J plus plus. No need to do all this check actually. If all are zero, then print. Else, if okay, no need to do all these things. Just check. If all are one, check all one for x belong. If x not equals to one, check one equals to zero. If check all one, then I just do answer dot push back one and then print else. What the hell now? Documentation program. Vector. Where's the where did I take the input as well? What is this? Okay, I think this should work. What is this? 40, 20, 10, 5, 2, 1, 1, 1. What the heck? 40. It becomes 40, 20. Yes, sorry, 40, 0, 20, 30. Again, 20. 20 it becomes 20, 20, 0, 10. Again, 10. It becomes 10, 10, 10, 0. Again, 5. It becomes 5, 5, 5, 5. Again, 2. Okay, 2. Then it becomes 3, 3, 3. Again, 1 is 2, 2, 2. And 5 के बाद 2 आया. It becomes 3, 3, 3. 1 will make it 2. 1 will make it 1. 1 will make it 0. Okay, fair, fair. Okay, let's just go and submit. So it was a simple idea. I turned it complicated. We could have thought it in even odd terms and then it could have been very simple. So I was thinking with GCD and the idea was actually the same. I could have broken down the idea better and before writing the solution. So GCD I thought. And then the 40 was like not even needed to be checked. So why was I checking that? Don't rush into code. Just think if that's not needed, don't use that. And then the even odd idea. If I say, yeah, I had already thought of that, right? If all are ones, then it's possible. And what am I doing? I'm dividing. Okay, this starts changing. Yes. Okay, okay. There's one more question we need to do. Is this one? You're given an array A of an integer and Q queries. Okay, let's try to solve this one. A integers and n queries. Sorry, Q n integers and Q queries. Each query is represented by two integers L and R. The find task is to find for each query two indices I and J or determine they do not exist. For each query two indices I and two integers. Query is represented by two integer L. Okay. Yes. Okay. It has two indices I and J. So that I L और R के बीच में J is also LR के बीच में AI H and not H. Okay. For each query, you need to find pair of different elements from AL to AR or report that such a pair does not exist. And will zoom in so that I don't see the topics because that is not there during the first line of input contains single integer t. Okay, okay, fine. Third line q queries. It is currently. But what do we have to do for which? Hmm. Does it for each query two indices ij each in other words, okay, okay, pair of different elements. That's it. The question sounds trivial. What's the q? 2 in 10 power 5. So then n is also 10 power 5. So I have to answer it in O of 1. And then it'll be okay. So let's say I get the query 1 to 5. Is there two different? Yeah, there are two different. Can I do a prefix thing? So the prefix thing, if I have till here there are five different, till here there are three different. No, but I cannot subtract and find out, right? Yeah, it's not possible to find out using prefix. What is another way? Making a map, what's the range of the numbers? The numbers are 10 to the power 6, right? We can make a map. Each place we have frequency of all the elements. And then R, I have, then L minus 1, I have frequency of all the elements. And then what I need to do is go over the map and then check if I can. But going over all the elements in the map itself is going to take lots of time. So what if I take all the queries together and then try to return the answer for that? What happens then? So I take all the queries together and then what happens then? 1, 3, 2, 7, everything I have, and then okay, it should have the L comma R. Yeah. That should work, right. So can I always go over? Yeah. So we need at least two different things, right? Let's do a sliding window. Sliding window. I go over all the windows which has at least two, right? Uh, I can go over all the windows on the array which has at least two. So anything beyond that range will definitely have more than two. So I can do that, yeah. And then I have list of all these queries. So in the list of queries, I sort the list of queries by the start value. Yeah. Right. So I have the start value and my sliding window. If my sliding window start value and the queries the current element in the query start value that matches, then the answering the query is easy, right? The right side, if it is greater than equal to my sliding windows j, like right side of the then yeah, it's possible. It's possible. We have to just give possible, or do we have to give ij? Okay, okay, let me check. Just to find. So what do I return? 2 1 minus 1 4 2. Okay. I return the indices. Okay, okay, cool, cool, cool. Even that works. So can I maintain the indices when I go over the sliding window? Can I also maintain the indices? I think I can. So if I am going, how do I maintain a sliding window? So I have a map, and then I do need to erase or add from the map. And then if the map size greater than 2, I say yeah. So what do I do is I am keeping the frequency of element in the map, right? There can be one more map which can just keep the position of the element. That works. Yeah, that should work, right? If there's an element. So I am keeping the frequency, right? This is this much, say, then I come from here. So my map actually won't be very big. We'll have just two elements, right? Yeah, just two elements all the time. Never more than two. Yeah. So the map is a very small map. We'll have just two elements. I don't know why am I taking a map. Uh, but yeah, let's take a map. It's easier to add and erase from the map. So yeah, there are always at max there will be two elements. So these two elements I just need to note down their positions. And whenever I have to remove one element, I just remove it and then the position. Okay. Whenever I remove element, I have to remove the position too. And whenever I have to add a element, I just update the index. So the frequency of let's say first element is 5. So 5 times the indices. So any one index. So I can just update the index. It should work. It's not a big deal. And then, okay, I think I understood. And then just update the index. Right. So I'll write it. Copy. Uh, I don't know why if I write on the laptop, why does it feel more easier? But actually, uh, what I notice is if you write it on your copy first, then you write the correct code. So let's say I have this I and J, and then what are you doing? You have a map, okay? You also have a map, uh, comma, and you call it. First one is just frequency, and then second one is position map, okay? So what you just do while mm, I less than n. I is the left side of the window, so I'll increase it. So while j less than n and np dot size is less than 2. So we want to make it. So I do this. I think this code I can directly write here. It's fine because so I have a map intent. This is the frequency map, and then I have a map int. This is the position map, and then while I less than n, I have an sorry, I have to take the input for entire zero, and then I have to take in queries as well. There will be n queries again, and okay, there's queries. Q queries. P and Q. And then your push back. Okay. Okay. This one. And is it one index, two index? I think it's better you see all that thing later. First, you write your logic indexing one or zero, all that thing you check later. First, you write the logic here. So sliding. So I just done it. And then you check if frequency map size is less than 2, then you have to keep on increasing j plus plus. So how do you increase? So you do frequency of array of j. Sorry. Yeah, you increase this and then you do a j plus plus. Okay, okay. And then here what we have, just add a condition k less than and okay. And here what you have is your frequency should be equal to 2 or the j has reached the end. So if the frequency dot size is equal to 2, then what you can do is you can just do your stuff uh, and and then you increase your I. But how do you increase frequency of array of I? You decrease if the frequency of array of I has reached 0, then you do mp dot erase array of I, and then you do I plus plus. Okay, so this is how you can do this. But one thing you need to worry over here is the position map. So whenever you add this frequency, why don't you just go on the position map and then you do position map array of j equals to k. So you have the position, right? You have one position for array j and you get the position for array I. Yeah, this is what I need to do. And but when you remove here, and there's no frequency. So why don't you erase from here to frequency? Frequency. Erase from here to postmap dot erase array of one. Anyways, you don't need to erase because postmap is just the position will actually be referring frequency and then we using the postmap. Okay, fine. Anything works. And this should work. So here we take in the queries, we process the queries. So basically what we do is we will be somewhere in the query, right? So we will just process the query till whatever. So we take in query, right? So we will also do keyword sort based on the first element. So it automatically does that. Sorry, it's not keyword sort. It's sort keyword begin keyword dot end. And then after it sorts, what you have to do here is just go over the, let's say there's a K which goes over the keyboard thing. And then there's your answer vector. You can directly print out the answer. No, you cannot actually. Okay, sorry. So you cannot actually just sort keyword. You need to add the index of the query to, and then you can do the sort because at the end you also need to rearrange your answer to match the order of the query. So then you will be able to make that. I think it was question. Okay. Okay. Let's do this. Okay. Mm, okay. Okay. 1 to n is given, right? So if you see one of the 1 to 5, 1, 2, 3, 4, 5, 6, it's a one index thing. So let's just subtract. I can just subtract L minus minus and R minus minus and then add. We just add the position to I. Okay, works. And then I sorted. The sorting will happen based on the L. So the first element of the QR. And then we can have index k equals 0. And then here I can do for int k. I don't need to put k less than QR dot size. What is the QR dot size? I think q k plus plus. And I just answer the queries. So L is equals to what's the vector QR? QR of k, and then L should be the first value, and then R should be the second. K. Mm, 1. Okay. And basically in the answer, I just need to put it in the correct position, right? So answer of QR of k 2 equals to whatever the answer is, okay? So whatever the temp answer. So this is the index, right? So let's just make an answer vector. And so answer is also a vector of vector answer, and the size will be q itself. Okay, okay, works. Hmm. Okay, so this will be equals to temp is a vector. So let's uh, vector int temp. This is size 2 vector initially filled with -1. So let's see if R is greater equals to j plus plus, okay. So when I had equal to 2, I did a j plus plus. Now it checked that it's equals to 2. So I am one index ahead of 2. So this is 2, let's say. This position is 2. And j is actually on the next index. So R, if it is greater equals to j minus 1, then it works. Mm, sorry, first let's see, check the L part and then we'll check the R part. So first, while hmm, L is less than I, if L is less than I just L is less than I have to increase K plus. Continue. I don't need to put while. When L reaches I, now L is equals to I. So I'll just check the right. If right is what happens if L is greater than L is equals to I, we do this. Else